Good morning, everyone. We are Group 2, and today we are excited to share our journey in developing our food delivery system for the course software engineering. My name is Muhammad Danish bin Azhar. Okay, so here is our teammate. Okay, we go to the next slide, project overview. For the objective, we are to develop a comprehensive system for food delivery. Okay, the next slide is core functional modules. The main goal of our project was to create a seamless digital bridge between hungry customer and local food vendors. Our system cover everything from user registration and menu browsing to secure payments and real-time order tracking.
Okay, next key decision. Choosing the agile model. Why Agile Scrum? First, complexity. System has many integrated module, vendor, user, and payment. Next, flexibility. Allow for change in desirable or optional requirement without starting. And the last one is team collaboration. Facilitates daily discussion and task division, front end, back end, UI, and UX. The development journey, the sprints. The sprint. Requirement gathering and prioritization, mandatory versus optional. Then iterative design of UI, UX, wireframes, and database scheme. Next, core feature implementation, login, menu, card. Then the last one, we have advanced features, payment, real-time tracking, and continuous testing.
This kind chart outlines our project plan from January to the end of April. We began in early January with project integration and team step cycle, followed by a requirements analysis to clearly understand the system needs. In late January and early February, we focus on system, UI, and database design, making sure the overall structure is well planned before development starts. From mid-February to mid-March, backend and front-end development are carried out in prior to improve in phases. After that, we proceed with payment and API integration, and then system integration to ensure all components work seamlessly together. In April, the project enters the final stage, including system testing, bug fixing, and performance optimization. Finally, we complete development and documentation by the end of April. Overall, this timeline allows clear test allocation, paper testing time, and ensures on-time project delivery. Thank you.
Hello guys, my name is Mogan Kumaran and my matrix number is 301884. So now I'll be continuing to the part where key challenges that is encountered. Okay, the challenges first is security risks, protecting user data and preventing breaches. Second of all is technical mitigation integration. Ensuring stable payment gateway processing. And third of all is performance, maintaining a load time of 3 seconds, more or less, 3 seconds with 1,000 concurrent users. And finally, requirement complexity, managing real-time order status updates. And the next part is risk management and solutions. Okay, identified risk is payment gateway failure or data breaches, and mitigation strategies are implementing HTTPS and password encryption, and then regular unit and integration testing during every sprint. Third one is contingency planning for server load issues. That's all from me. Thank you.
All right, Danish, thank you for the introduction earlier. My name is Akimat Rio, and I will be explaining the methods used for the software testing in our project. So there are three black box techniques used in our software testing. So first of all, there's the filtering logic, which is used in testing if restaurants show based on the correct location. After all, for our food delivery service, we will need to know the restaurant's location so that they may upload their menu as well as be ordered from properly. So the drivers can also detect and find where the restaurants are and safely deliver the food to the customer. Next, we have the search functionality, which is verifying the keyword and accuracy and boundary conditions. This refers to when you search on the search bar of our application, we will be able to find the restaurants or the menus that we need. Lastly, we have the usability. Now, usability is ensuring the full menu displays correctly, or the restaurants show up when you look for them, or other things like with roadmap they can actually connect to the server, etc., etc. Anything functional, basically. So here we have our first set of test cases, which reflect what the users will do in the application. So first of all, we have the of DO1 test cases, which refers to the registration and login processes that the users will go through. So OFDO 101, we have user registration. So self-explanatory, it's like registering with valid details. And what we need to do to test is that we will input a valid name, email, password, etc. And then the expected result is that the account is created successfully and the user is then redirected to the login page. Next, um, we have OFDO 102, which is the wrong test case actually. So where we put it in valid email format. And self-explanatory, we register with an invalid email instead, and we will input an email address without a key symbol, for example, the app. And what we expect from this is that the system will display a validation error message in registration, and yeah, it will not allow the user to register. Lastly, for the first set, we have OMD 103, which is login and log out. So we will try and log in and log out securely. And first step, we will log in to account with correct credentials, and the second step, we will log out of the account. And the expected result, obviously, is that we will succeed in the login, and the session, aka the application, will end after the logout. So now we have our second set of test cases under the test case ID OFDO2. So this one actually refers to the tracking or the location services of our application. Okay, first of all, um, we will filter restaurants by location. So self-explanatory, we will set a delivery address. And once we set a delivery address, our expectation is that the application will only show restaurants near us or within our reach, because otherwise they'd be searching for every restaurant and there'd be a problem, obviously. Next, we have RDO202, which is search restaurant or item. So this is also self-explanatory, which that we will search by a product or a cuisine or a food name. And what we will do is that, for example, we will put in pizza in the search bar. And our expectation, obviously, is that the search will give us pizza as a result, or like restaurants containing pizzas as a menu. And lastly, for OFDO203, we have fuel menu. I have very sad news. This is also self-explanatory. There's not much to explain. We'll just select restaurant from the search, and once we select restaurant, hopefully it shows us the restaurant's item names, descriptions, prices, as well as images if they have put in any. Okay, we have our biggest table yet, which is the third set of test cases, and this one reflects the ordering process of our application. So OFDO 301, we have add item to cart. So first of all, this is self-explanatory. What we will do is that we will select an item and we will customize the item, and then we add it to cart. So what we expect from this is that the item will appear in the cart with the changes that we made reflected accordingly. The next three test cases will not have any steps because what we do in the test case name and description itself are the steps. It's like a single step procedure. So FDO 302, we have order summary calculation, which is view order summary. So this will display the subtotal, the tax, the delivery fee, as well as total, and they are calculated as well as displayed correctly. FDO 303, we have apply promo code, where we will apply a discount voucher, for example. And what we expect from this is that discount is applied and the total of the purchase we made prior will be updated accordingly in the final screen. Lastly, we have OFDO 304, which is track order status. This is also self-explanatory, where we will see the status of our order, and we will be able to track where the restaurant or the driver is at right now. For example, is it like preparing? Is it out for delivery, or is he just outside of our door? So next we have two test cases simultaneously, which I have decided to combine because they literally have no steps. So first we have the test case ID OFDO4, which refers to the payment, where the customer will pay for their order. Say to the point, OFDO401, which is a payment gateway selection, which is where we select the payment method, like let's say the card, e-wallet, etc., etc. And that's how we will see the result. That's what we expect, that it will show the payment gateways. Next, we have OFDO402, which is payment processing, where we confirm the order and pay up. So what we expect, of course, is the payment is processed and the money is deducted. And OFDO 403, which is refund handling. Worst case scenario, the customer doesn't like the order or there's problem with the order. So what we expect is that once the order is canceled, a refund is actually issued to the the customer, and the amount is the expected amount, which is the original payment amount. Next, we have the test case ID of FDO5, which refers to the vendor side of things. So FDO 501, we have vendor receives a new order. Self-explanatory, the vendor will receive an alert when the customer orders from the vendor. So what we expect from results is that the vendor dashboard receives an instant notification notifying the vendor. OFDO 502, accept or reject order. Since the vendor has full control of their store, they can reject or accept the order that the customer has sent. And what we expect from this is that, of course, the order status will update based on the vendor's choice. Did the vendor accept it and is cooking right now, or did the vendor reject it maybe because they're closing? And lastly, we have OFDO 503, update menu. So yes, vendor will be able to update and edit their menu if they have a, let's say, a promo, a new menu, a price change, etc. So what we expect from this is, of course, the changes will reflect immediately on the customer side, letting them know if there are any changes that need to be notified of. Okay, we're at our last set of test cases, which are non-functional test cases. So these test cases or these scenarios actually do not affect the basic performance of our application. These are what gamers would call min-maxing. So we have our three test cases here, and we will start with OFDO6, which is security. OFDO6A, which is that we will verify the passwords are encrypted in a database, because obviously we do not want the user's login credentials to be visible to anyone else to ensure that their account is protected. OFDO6B, we have attempt unauthorized dashboard access, and hopefully it will deny access, because we expect that the security of the system will actually protect the users from unauthorized logins. OFDO6C, which is that we will verify HTTPS is enforced. This will happen later on. It's not much to explain. OFDO7A, we will now go to performance. Homepage loads within 3 seconds. Yes, this does not affect the base performance at all. We just expect that the homepage loads within a reasonable amount of time, or maybe even a fast amount of time. And this is just about the comfort and not the usability, more or less like the speed of access for the user. Next, we have Audio 7B, which is order confirmation completes within 5 seconds. This is more or less just the speed again, and we just expect that the order will be confirmed in a reasonable amount of time, because obviously what the users want is that the order that they make is confirmed in time, because they are maybe hungry, they need it in a certain time frame, etc., etc. Last, for the performance, we have Audio 7C, which is that the system can handle 1,000 concurrent users. Obviously, since we expect that there will be a big number of users in our system, because they will be ordering food, simultaneously. So we do expect that the system can handle at least, or maybe an expected amount of 1,000 concurrent users. Next, we have the utility category, which is OFDO8. OFDO8A, we have new user completes order within 5 minutes. So this is just an explanation that the accessibility as well as the ease of use on our application allows for new, like fresh users, to complete their orders within 5 minutes. And this will just prove that our app is as accessible as we advertise it. Of the O8B, we have the app does not crash during normal usage, because obviously if the app does crash during regular usage, what will happen if there's a, let's say, a rush hour, or maybe the user will give us bad reviews if the application does crash when they're just using it normally. Nothing like overloading. Lastly, we have OFDO8C, which is the last of the utility and the last of non-functional test cases, which is mobile and web UIs behave consistently. Obviously, we expect that the UI for the application will be consistent and you know um, ready and available for the users to see and use. And obviously, if the UI isn't, it's not a if it's not constantly available, it can always be optimized, and so it does not affect the overall, or like the base performance of the application. So that's it for my section, and I'll move on to the next section.
Okay, we go to the next slide for the mockup. Okay, for here, we have the mockup for the login, restaurateurs, and menu list. We go to the next. At here, we have a shipping cart and left order tracking.
Now we move to learning outcomes. What we learn: technical growth, understanding system architecture and secure data transmission, process knowledge, experiencing the benefit of agile iterative development, teamwork, learning to manage rule, project manager, analysis developer over a four-month timeline. Conclusion: the project successfully applied software engineering principle to create a scalable food delivery solution. That's all.